Chapter 3, starting off chapter 3 with the law of sines. So you will get this same image on a handout to make sure that you will always have this. Now, there are different ways that we can represent a triangle to figure out the missing parts. We have angle, angle, side, angle, angle, side, 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 angle, side. 4 law sines. The ways that you can solve for the missing pieces are using angle, angle, side, or angle, side, side. So these 3 are law of sines. The other ways will be law of cosines, which will be 3.2. I know, you just can't wait. So first, if I have an angle, angle, side. So again, when you're setting up this triangle, opposite large C is small c. Opposite large B is small b, and opposite large A. So I should say capital and lowercase, but I didn't. If I want to use law of sines now, whatever match that you have both of is our ratio that we're going to be working with. So in this case, I have B and little b. So if you look at that, that means your length, so 28 over sine of my angle, which is 29, is what I'm going to be using for both of them. Sine of 29, because that ratio is going to be the same, and it doesn't matter which one you use. So let's say if I set up A, so I'm looking for, actually, let's find angle A first. How can we find an angle? This is bringing it back to your younger years. All the angles in a triangle add up to 180. So you can have angle A plus 102 plus 29 is equal to 180. You would get that A is equal to 49 degrees. So that's one of our missing pieces. So now when I'm looking at my trig functions, we already have our angle A because we just found that. So we need to figure out little a, and then we can have that over sine of my angle, which is 49. When I'm looking for my little c, I'm going to have my little c on top over sine of my angle C, which is 102. And I can solve both of those 2 ratios. Both of them have divide by of something, so I can multiply that over. Make sure you got A is 43.59 feet, because length here is in feet, and C is 56.49 feet. One thing you could always check is your largest angle, which is 102, should be across from your largest side, which it is, and your smallest angle, which is 29, should be across from your smallest side, which it is. So that works out. So looking at this second example, so you should pause the video and read that if you haven't yet. So if I'm looking at this, I see that I need to figure out what A is. It's asking for how long this pole is right here. So I'm looking at this pole. This also creates a triangle. So using that triangle, I can see that this angle right here, because this is 8 degrees, I know it's kind of hard to see, is 98 degrees. Well, to use law of sines, I need an angle across from the given side. So I need to figure out what this angle is. Here's that mighty old triangle, and you know that 98 plus 43 plus C is equal to 180. So angle C is equal to 39 degrees. So now I have my lowercase, my side length over sine of my angle will be equal to my side length, which is A over sine of my angle. Again, you are going to be multiplying by the sine of 43. You should have gotten 23.84 feet. And now we get into this ambiguous cases. So whenever you're given an angle and a side, which is a naughty word, so that's why we typically say side, angle. There are different ways that you can represent that information. So if you're given this information, you could have no solutions because there could be a spot where you can't actually create a triangle with that given information. You could have one solution if A is acute. You could have one solution in this format also, or you could have it if A is acute, you could have also 2 solutions depending on how that angle looks. If A is obtuse, there's definitely none. And then depending on if A is obtuse, depending on that side length, it could have 1. So how do you actually know? Well, for this first one, I'm already telling you that it is a one single solution, but I'm going to go over how do we actually know that. So again, the first thing we want to do is set up our equation. This is what we have here. We have the A's right here. So we have 2 different equations we can set up. But we want to figure out the angle B first, because with the angle B, that will kind of be our indicator if there's 1, 2, or no solution. So when I'm looking at my angle B, because we have this side length right here, we can have our 12 over the top over our sine of B. Now, one thing, I didn't have to write it in this format. I could have, because it's a ratio, I could have also written this like sine of 42 over 22 is equal to sine of B over 12. And it's kind of up to you how you want to write it. In this case, it's actually easier to write in this format. Why? Because all I have to do is multiply this 12 over to get the sine of B by itself. And the inverse trig function of sine is sine to the negative 1. So if you put that into your calculator, you would get that angle B is equal to 21.41 degrees. That's our angle B. Now, this is at the point where you would want to check to see if you have one or two answers. Again, I am telling you that we have one. However, how we can check this is, if our angle right here is 21.41, that means our other angle that it could possibly be has a reference angle of 21.41. Okay, so we would want to figure out what this angle is. So because we have this 180, this angle right here is going to be 158.59. So how do we check if this works or not? Well, we already know one of our angles is 42. So to check if this works, if I did 158 plus 42, if I added 42 to that, I would get 200. Well, already that can't happen because this angle plus this angle still has to give me one more angle. So it has to be equal to 180. So since already two of the angles, this plus this is over 180, there cannot be two answers. So we have our sine, or we have our angle B. So now we can figure out our angle C by doing 180 minus angle B minus angle A. And now that we have our angle C, we can use that same trig function for our sine of law of sines, except now our sine length, little c, is going to be over sine of 116.59 because that's our angle C. So if I multiply that over, you will get that C is going to be equal to 29.40. So yes, I want you to round to 2 decimal points, and in this case, our units are in inches. So 3 missing pieces. So there's no triangle here. However, we can draw a triangle just as a reference point if it's more beneficial to you. And we have both a's, so we know our trig function that we're working with. Our law of sines ratio is going to be little a over sine of big A. So this is the reference we're looking for. We have our little b, so we know that this is 25 over sine of b. Again, I would probably rewrite that. So we can multiply that 25 over, because you want to get rid of that divide by 25, so multiply that over. At this point, this is where you actually want to check to see if there's a solution to the problem. Because if you plug this into your calculator right now, you get 1.66. That's without doing anything with this sign right here. Well, we know, because we are very smart individuals, that sine and cosine, just remembering, sine and cosine bounces. It goes, and the highest it ever goes is 1, and the lowest ever goes is -1. So it cannot be greater than 1, and it cannot be less than -1. So because this ratio right here is greater than 1, that means it can't happen. However, let's say if you try to do the second sign to this answer, you would get an error. So it's going to tell you it can't happen. Moving on to question 5. So same type of thing. Right now, you should pause the video and try to set up the trig functions first. So this is what it'll look like. Now we have to multiply that 31 over. Check to see if we do have a solution. Take the inverse of that equation, and you will get that b is equal to 64.78. So what we want to do here, we want to look at our two possibilities. So this right here is 64.78. The reference angle over here is 64.78. So I'm going to do 180 minus 64.78. So this angle right here is 115.22. So how can we check? We know that 115.22 plus this other angle. So if I do 115 plus 22 plus 20.5, that is 135. So I know there's going to be two cases because I know that I can find another angle there that could add up to 180. So at this point, you're going to have two cases for the remaining information. So now to figure out our angle C, we can do 180 minus A minus B minus A minus B for both of them. And for our remaining length here, so for this one, again, we can always start with that sine of 20. So if we have our sine of 20.5 over 12, I'm actually going to do 12 over sine of 20, and then our sine of 44.28 for this equation, and sine of 94.72. So for both of these, you're going to multiply, and you're going to multiply to figure out that sine, or so that missing length. So these would be our 6 different answers depending on which way the angle and the side length is. And last but not least, area of a triangle. So these are the 3 different ways that we can find the area of the triangle depending on what the angle is that it's given. So again, these are 3 different ways depending on which side lengths are given to you. So this one says find the area of the triangular lot having 2 sides of lengths 90 and 52. And I put this picture here, but this picture is actually for this one. So this picture has nothing to do with this question. And we should draw up a picture to represent. Whenever there's not a picture show for any word problem, you should draw up the picture. So it's saying the included angle. So it doesn't really matter which ones you're doing here. So let's say if I have this is my included angle B. That means one of these lengths are 90 and one of these lengths are 52. So this is how the picture would look. Again, it doesn't matter where I put the angle because there's 3 different ways to do this. So because we have our angle, this is the equation we're going to be using. So we would have 1/2, in this case, times our A, which we have labeled here as 52, times our C, which is 90, times sine of our angle, which is 102, because that's our B angle right there. If I put that in my calculator, and if I round to the nearest, in this case, meters would be 2,280 meters squared. So now looking at example 7. So if you didn't already, you should read that, pause and read. So using this picture, it's saying find the total distance of the race course. So one thing about this picture, that if you remember from geometry, this right here, alternate interior angles, because you make this Z or an N or however you might want to think, but this angle right here is going to be 40 degrees. So I can figure out this missing angle, angle B in that case, with that triangle, the race course, and I get that this is 88 degrees. So now I want to figure out how far did this boat race actually go. So the length we have 8 and 88. So we're going to have 8 over sine of 88, and we can use that for both equations. So in this case, we have our A on top over sine of 52, and on bottom, we're going to have our C on top over our sine of 40. So if we solve for both A and C, well, the actual question is, what is the distance of the race? So approximately, adding those 3 up, because that's how we find the perimeter, would be roughly about 19.46, in this case, kilometers. There you have it. Have a wonderful day.